Now,
Uh,
let me ask you this:
yeah.
Are you familiar that they're finding soft tissue in dinosaur bones?
Are they? I haven't heard of anything yet. I've heard of evidence of them finding, evidence of soft tissue, but I don't think I've found anything. Oh, actually, no, I'm lying. I've seen something about mammoths being uncovered from
Not mammoth.
ice that still preserved some of their soft tissue. So,
I know. I'm not. I said dinosaurs, not mammoths. Are you
okay,
familiar
yeah.
that they're
As
finding
for
soft tissue in
dinosaurs, no,
bones?
I haven't heard of anything like that yet.
Now, the funny thing about this is the reason why you haven't heard this, for the most part, is because evolutionists don't have an answer for it. Now, they're trying to come up with an answer about how iron in the blood creates a matrix and preserves it, but they have no clue. Now, I'm not going to show you the whole thing here. I'll just give you enough so that everybody knows that I'm not lying to them. This is not new. This is testable and repeatable, and it's
I
I don't
can't
want
see
to.
it.
I know. I'm turning it on. Hold on, give me a second. So this is 60 Minutes, right? This is an interview done with a paleontologist called Mary Schweitzer. And this was actually done. It's going to play a commercial here. Hold on. This
I'm
was actually done
listening
15
and
years
watching, by
ago.
the way.
I got you. I got you. This was done 15 years ago. 15 years ago, we've had this science. And the reason why you probably haven't heard about it today is because evolutionists don't have an answer because soft tissue can't last for 65 million years. And this one right here is supposed to be over 100 million years. Oh, come on with all of these commercials. I'm gonna let this play out and then I'll show you. But it's testable, it's repeatable. Most of your people doing it now is young Earth creationists. But I'm showing you this interview with Mary Schweitzer on a 60 Minutes because obviously she's not a young Earth person. She believes in millions of years. 68 million years old. So let me go back here a little bit so you can see it.
Away the outermost layer of mineral, but the acid worked too fast and all the mineral dissolved away. Being a fossil, there should have been nothing left, but there was, and it was elastic, like living tissue.
This is the piece.
No. She showed us video she took under the microscope.
That's really what happened?
Yes.
That's the dinosaur bone?
Without mineral now. That's what was left. It looked like the soft tissue she would have expected to find if it had been modern bone. This was impossible. This bone was 68 million years old.
So 68 million years old. So this was supposed to be 68 million years old. They put it in an acid that dissolved all non-organic material, meaning minerals. And what they were left with was clearly organic material. So that's why they call it soft tissue, is because it's non-bone and it's organic dinosaur material. That cannot last 65 million years. There's no preservation technique that can preserve that for 65 million years.
I mean, but wouldn't you say it would be more fair to say like, wow, like this is a groundbreaking like scientific discovery than just assuming like, well, it must have been the flood. You know what I mean? I feel like as since science is constantly like an evolving
It
uh
is. It is. Hold on, but
thing,
it
then I
absolutely
would say
is
it's more fair to
groundbreaking.
say that, it's a scientific discovery that we're still trying to
It's
figure out the reason
it
why.
is. Why would you not go with the conclusion? That's my point. That's a religious viewpoint. That's a religious viewpoint. When you see something that clearly goes against your viewpoint and you just decide to go with it anyway, I'm not necessarily mad with that. Nothing's this is not the rock hard truth, but that is a more of a religious viewpoint. There's no mechanism that can keep this tissue for 65 million years. So when you see it, it's absolutely groundbreaking. It's groundbreaking in the fact that they found soft tissue. And again, this is not a one off. They've tested and repeated this now several times. So they can repeat this, right? So it's testable
Mm.
and repeatable. It's part of science. You can get soft tissue out of dinosaur bone now. So it clearly shows that it's not 65 million years old. You're right. That's absolutely groundbreaking. It absolutely spits in
I
the
don't
face
I
of these
don't think
evolution.
I don't think just because they found a way um to find soft tissue preserved on bones, I don't think that's a reason to why it's not 65 million years old, because that's just assuming that, I mean, now we know that there's certain processes that take place that that there can be some sort of or some level of soft tissue preserved on bones. Before that, we assumed that, that was not a thing because we just didn't discover it. But then we discovered it, like, wow, you can preserve soft tissue on bones. Like, then they figure out the reason, but I don't think that's
So they haven't
that
figured out.
correlates
They
to
haven't.
the claim that the fossil isn't 65 million years old. It's like
All right.
before,
Well,
like we thought the Earth, we thought the solar system revolved around the sun, but then we discovered that in fact we revolved around the sun. You know what I mean? So
you
it's
know
just
what?
like
You know
another
what?
discovery,
You know what we
and it
should
just
do? You know what we should do? When we find out that there's irrefutable proof that we actually revolve around the sun and not the other way around, then we should change our viewpoint and say, okay, this is now a truth statement. Instead, what you're doing is you're taking a truth statement that these dinosaurs cannot preserve soft tissue for 65 million years, and you're turning it into a faith statement saying, well, I just believe that they can, and we haven't figured it out yet. Right? We can do decay rates. We know what the decay rates are on items in perfect preservation methods. You can look up the studies. I can give you the paper if you'd like. Right? You can look up the
but
studies that they've done in perfect preservation techniques cannot make it last 65 million years. You're choosing to believe that by faith. That's a
no, but
religious view.
they already found the explanation of what can possibly cause
Oh, please. What is it?
this kind of this level of preservation. It has to do with
Give it to me.
iron and and hemoglobin.
It's not true. It's not true at all.
That's what that I briefly like looked at it
I
on
know.
the internet, and
I,
that's
I
what
know.
popped
I
up.
know. I know that it said that, brother. But here's my thing: I don't want to pretend like it's a conspiracy theorist or anything like that. But I promise you, they are factually incorrect. I'll give you the sources, okay? So the paper that the Google thing that you're asking right now, the paper that it is referencing. Let me pull my source up here, and
Wait, hold up.
it's
So you just said that uh new information came up, and I'm just choosing by faith just to believe it because, but
yeah. So let
for
me.
X, Y, and Z. But the explanation for behind this
Brother,
new discovery
I know. Hold on
was
just a second,
already,
okay?
you know.
I know. Let me just help you out, okay? Because this is what I said I was going to tell you. So let me tell you. So the scientist that did this iron in the preserving the blood sample, right? That's what you just stated. I know that the paper on that was done by Mary Schweitzer, okay? And the actual paper is called A Role for Iron and Oxygen Chemistry in Preserving Soft Tissue Cells and molecules from deep time. That's the name of the scientific peer-reviewed paper that's claiming. Here's what they did: they took iron-rich blood and they put like ostrich DNA inside of it, also, to get iron-rich thing, and they put meat inside of it, and then they seen if it would slow the decay rate. And yes, it will slow the decay rate. But here's the thing that you need to understand: that mechanism slows decay 100%. It does not prevent decay. And they did not do any decay rates. Mary Schweitzer and them absolutely outright refused to put out what the decay rate was. And that's because it doesn't last 65 million years. And here's a quote from that paper that Google is intentionally leaving out. The very first thing that Mary Schweitzer puts on that scientific peer-reviewed paper, her very first words, very honorable for her to put this in there. She states in the abstract, the first word, she states, the presence of original soft tissue in Mosaic fossils, Mesozoic, I'm saying that wrong, I apologize. Mesozoic fossil bone is not explained by current chemical degradation models. So the first words in this paper that Google is using to tell you this is the scientific method that makes it last 65 million years, in that very scientific paper that Google is using, she outright puts in it that this is not the answer. We do not know
Repeat that
how it's
quote one more
lasted
time.
for 65 million years. Yeah, she stated, she states in the abstract, the presence of original soft tissue in Mesozoic fossil bone is not explained by the current chemical degradation models.
And current meaning, when?
Meaning that they have no
Now
answer
or
as
20
to
years ago?
what would. This is what that means. She is stating that they do not have a sufficient model to make it last 65 million years.
When
This
was
is why.
that written though?
When was the paper written? I'd have to
Yes,
go to it and see. I think it's 2001 or 2004, if I'm not
that
mistaken.
was over 25 years ago. Can you find something more current?
No, I searched this today and I can't find any scientific papers that are testing iron and the rate of preservation. You can find it where they slow it down. That's what this is. But I cannot find where they give you any data on the degradation rate, meaning the rate of decay. So, for example, if you put something in a formaldehyde, right? It slows the decay, but you can still test the decay rate and you can extrapolate from that rate how long it will preserve it, right? Because we know through Newton's second law of thermodynamics, everything tends towards chaos and decays away. Eventually, everything will. That's Newton's second law of thermodynamics. So nothing stops it perfectly, but it does slow it, and it could slow it significantly. So what is the decay rate? You're not going to find that. And the reason why is because they haven't come up with a decay rate that gives them 65 million years yet. That's why Mary Schweitzer named the paper that Google is actually giving you the information on. They named the paper The Role Iron and Oxygen Play in This. So they're saying that iron and oxygen, right, creating this matrix type system, it can preserve or slow the decay, but they will not give you the decay rate. They said that's not part of the study that we did. We didn't do the decay rate.
Okay.
Well, why would you not do
I
the decay
I
rate?
I briefly just read over it and over some of it, and what I come across it to is that it says that um over the process of fossilization, the material's molecular structure is permanently changed by the minerals that encase it. So it kind of like reinforces the tissue. So it's not 100% fully organic, like just like a piece of meat just hanging off the bone. It's like a more reinforced version involving the minerals that prevent it from fully decaying. As
Correct.
for the part where they can't, again, this was over 20 years ago. I'm pretty sure there's something out there that gives it a better
There's
explanation.
not.
But
There's not. I looked at this today. There's not. And
the
you're going with the matrix argument, okay? So you're stating that it creates a matrix on the outside that basically preserves it on the inside. That's the matrix argument. If you do that, now you have a dilemma, okay? So it's called uh, I forget. I can't think. My mind's having a blank. When it leaching, I'm sorry. It's called leaching, right? When you bring an outside material and bring it in, it's called leaching. Okay. So leaching is what happens when you replace the bone with mineralization. The minerals are leaching into the bone and replacing the bone. So technically, it's supposed to be all mineral now. So if you're saying that created a case, which is what you just called a matrix that preserves the soft tissue, now you have a problem of C14. So carbon 14 has a half life. This is I don't know if this actually has a name in it, but I call this the tissue issue dilemma. That's I've named it that personally. That's my personal take. The tissue issue dilemma, because if it creates a matrix that does not allow leaching, meaning that it preserves the soft tissue, then now you have to assume that the C14 that is found in it is original, and that proves that it's not millions of years old. So you have to have the reason they're finding carbon 14 in dinosaur bones. They claim that it's leaching, meaning groundwater is bringing in C14 and placing that inside the dinosaur bone, because you should not find any carbon 14, any measurable amounts of carbon 14 in dinosaur bones. So if you go with this theory that there is a matrix that preserves the soft tissue, then it doesn't matter which way you go, you're going to have the soft tissue issue, right? Because if there's a matrix that preserves it, then the carbon 14 proves that it's not millions of years old.
Hey, host,
If
can I
you
say
remove
something?
the matrix and you allow leaching to take place, then that's fine. But now you have a problem because leaching does not allow the soft tissue. So if there's leaching, the soft tissue proves that it's young. If there's a matrix, then the carbon 14 proves that it's young. It's a dilemma. Any way you go, proves that it's going to be young.
I'm
Can I
not.
say something
I'm
real quick, host? Can I say something real fast?
Yes, sir. Yes, sir.
Yeah, I'm curious to Alejandro, why is he not questioning the fact that they will not release the decay rate, man? You should be asking that question. Yeah, I mean,
um
you kind of overseeing what he's saying. The
no,
key
I
thing is that they left out the information that you're not willing to even ask yourself. Like, wait a minute, why are they leaving out the decay rate?
no, I'm not saying that.
Don't you want to know why?
No, I'm not saying that they're leaving out the decay rate. They just probably don't know yet. Or at the time when the paper was written 20 years ago, they probably didn't know yet. You know what I mean?
So
You
I
saying
want
Like I
to
keep
be
said,
probably?
very, I want to be
science is
very clear with.
is a continuously evolving entity. You know what I mean? So
Let me be
that's why
very
I'm
clear with
saying.
the. Let me be very clear with the accusation. The test lasted for over 2 years, brother. So there is no claim to them that they put out that they're hiding the decay rate. They're not claiming that, but they do know what it is because they put it in there for 2 years. So of course, in my opinion, I can't prove this, and you can call me a conspiracy theorist. But the whole purpose of the study was to determine if it slowed decay down. So if you had to determine that it slowed decay down, which is true, I believe that it does slow it down, then you have to know what rate that's reasonable. How do you know it's slowing it down if you don't know the rate of decay, right? Now you can compare it to something that's in a control environment, absolutely, but you still need to know the rate at which it's decaying. And the fact that that information is not provided is a problem for me because I'm like, the whole purpose of this iron in the blood test was to determine that it can make it last for 65 million years. And if the decay rate showed that they can make it last for 65 million years, you better bet your bottom dollar they would have printed that. But the fact that there is no decay rate in this study is a huge red flag for me.
There's more. There's some current studies that I just found that if you would like to, you know, just look
What
it
do you
up,
got?
briefly look over it. Uh,
Are they studying decay rates or what are they studying?
just that there, it's another other peer review studies based on that original thing.
Right. But if they're not testing the decay rate, brother, here's the thing. I grant and I believe 100% that iron will preserve the tissue. And well, let me say preserve. It will slow the decay rate down. 100%. I agree with that. It slowed it down by a factor of, for 2 years, right? This test went on for 2 years in Mary Schweitzer's lab, right? This was a 2 year test. This was not a 1 day, 2 day test, right? It went on for 2 years. So I would grant that it slows decay. If I put organic material inside of formaldehyde, that's going to slow the decay, but it doesn't stop it. And we can still test the decay rate in these items that are being preserved. So if the peer-reviewed paper that you're going to show me doesn't give me a decay rate, all due respect, I just don't care because I already conceded that iron will slow it. I agree with that. If you cut off the oxygen content, that will slow it, but it will not preserve it for 65 million years. You have to show me the mechanism that slows it to where it's not decaying enough to get rid of all of the soft tissue for 65 million years. They haven't found that mechanism yet.
You just said it yet though, so maybe in the future they will.
Well, that's an argument from silence, and I'm open. If they find it in the future, then I'll have to revamp my argument for sure. Absolutely.
Yeah,
But right
but that's
now,
the thing. It's like I don't think it's I think that means we shouldn't be assuming anything right now. You know what I mean? If
I,
they haven't,
I'm
if
not.
they come to a conclusion where
I'm not
they're just
assuming,
like,
brother.
yeah, we just hit rock bottom and we can't find a way to
Uh,
find an
let me
explanation for it, then I don't think we should be assuming anything
let's
yet.
okay. Let's find out who's doing the assumptions, right? I can give you the peer-reviewed papers that shows the decay rate, right? I can show you where they did a warm decay rate and a cold decay rate, and they put it in the best perfect position that shows that soft tissue in a cooler environment in the best conditions period will last about 100,000 years. That's way off from 65 million. I can show you those studies. That's what peer-reviewed science is. Now, I make no assumptions. The science says that soft tissue in the best agent preserving agents that we got will not last hundreds of millions of years. will not last tens of millions of years, will not even last 1 million years. It only lasts about 100,000 years. That's the best science that we got. Now, if something comes along, then I'm following that. I'm not making any assumptions. That's what the science says today.
No,
Now,
but the assumption that I'm talking about.
hold on. I've almost landed. The Google thing that you went to gave you half of the information and made you believe that the answer was iron and made you believe that they had found it, when the paper that they're referencing admits that it has not. So who's assuming?
No, the paper that or the Google thing that I read to you, it was not, it didn't say anything about
Ask it.
decay rates. It said that it gave me the explanation of why it happens. It didn't say anything about decay rates, and
The explanation's not true. The explanation. So if you just ask Google, I'm not telling you to look this up, brother. Look it up. Test me on this. When Google says that iron is the one that preserves it for 65 million years, ask it for a source. I bet a lot of my reputation on the fact that it's going to send you to the Mary Schweitzer test that I just showed you, right? It's going to send you there. I did this today. Now maybe where you're at, the different servers from Google might send you somewhere else, and I might have to eat some crow. But it's going to send you in this direction that Mary Schweitzer did this test. And yes, it preserves it, but it doesn't preserve it for 65 million years, and she openly admitted that. And you're not going to find, and I'm open, this is why I do this, you're not going to find a single source other than Google. You're not going to find a scientific paper that says, this is the answer and we know what it is. Google will say that, but Google's not a scientific source. And I'm showing you that the source that it's giving you, the source admits that this is not it. It says it is a factor in play, and we don't know what the other factors are that gets us to 65 million years.
Look up this source. It's called the Molecular Armor MIT study from 2024.
Molecular armor study.
Yeah, Molecular Armor MIT study from 2024.
And what is this going to tell me?
I'm gonna keep going back and forth just to read briefly what it says. Recent research from MIT study. MIT chemists identified an atomic level interaction
Brother, you're going in and off the app.
that shields collagen. Yeah, because I can't. I'm reading this off of my phone. An atomic level interaction that preserves collagen and something else. So I'm pretty sure in that,
What's the rate? Does it give you a decay rate?
I haven't read into the actual study. I'm just giving you the source and briefly explain it to you. I can read into it though.
You don't got to read it all right now. I will look into it, but right now I told you that I agree with that. I agree that there's mechanisms to slow decay. 100%, I agree with that. But I want to know the decay rate so that I can see if it's going to last for 65 million years. So far, I haven't been given any of that.